Chapter 11, Sample Problem 11. A very low friction merry-go-round, i.e. rotating platform, with a radius of 1.5 meters and moment of inertia of 50 kg/meter squared, is rotating at 10 rev per minute. A child with mass of 20 kilograms initially sits 1 meter from the center and then moves outward to the edge of the platform. Two students are discussing how to calculate the final angular velocity of the platform. Arno says, I think we have to use conservation of angular momentum. The distance from the child to the axis of rotation increases, so her moment of inertia increases. The total moment of inertia goes up, and so the angular velocity has to go down. But Bell says, well, I agree that angular velocity goes down, but I think you're getting the wrong value. We need to use conservation of energy instead of conservation of momentum because there is no collision here. The rotational kinetic energy is what's going to stay the same here, and as the moment of inertia increases, the angular velocity goes down. Which, if any of these students, do you agree with and think is correct, and explain? So the key thing for checking these is angular momentum will be conserved. L is conserved if tau external is 0, because the torque is the rate of change of the angular momentum. And in this problem, the child pushes against the merry-go-round, and the merry-go-round pushes back against the child. The friction is what moves the child outward. Those are both internal to the system of merry-go-round plus child, so the angular momentum is conserved. So that's certainly true. On the other hand, energy is conserved if no non-conservative forces act. But here, it is definitely friction that is moving the child outward. So that is a non-conservative force. Additionally, there's a pivot or an axle or something that this thing is spinning around, which is why it doesn't go skidding around the ground out from under her feet. And so that is also a force that we're not sure is conservative. So we can't use energy conservation. So our final conclusion is that it is Arno who was correct.